Alright, let's try another conservation of momentum problem. This is called an explosive interaction because we have Carmen and Judy in a canoe all together. 75 kilogram Carmen moves forward at 3.5 meters per second as she leaves the canoe. At what speed and what direction do the canoe and Judy move if their combined mass is 110 kilograms? Okay, so we start out with everybody together. Okay, so we've got mass 1 of Carmen equals 75 kilograms. Velocity of Carmen is 0 meters per second, because she's trying to dock her canoe. And then, so our momentum of Carmen is also going to be 0. Okay, so then we have the canoe. And Judy equals 110 kilograms. This is all our before. Velocity is 0. Momentum is 0. So our P total over here is going to be 0. So then in our after, our masses stay the same. Kilograms. Our velocity of Carmen is a positive because it says forward, 3.5 meters per second. So that means that her momentum is going to be 3.5 times 75, which gives us 262.5 kilogram meter per second. And I got that by taking my mass of 75 times my 3.5, because I'm going to do mv equals p. So now my p total, remember, has to equal 0, because this equals 0. Those have to be the same. So then I know that this P of Judy and the canoe has to equal a negative 262.5. Because those have to add up to 0. So the only thing that's going to add up to 0 here is 262 minus 262 gives me 0, because that was my total momentum before. So now I just use my P equals m times v again. My P now is negative 262.5 equals my mass, which is now 110, times my velocity. So I divide both sides by 110, and I get 2.39 meter per second squared, or seconds, sorry, and it's negative. So it means it's going in the opposite direction. So it's going backwards. So the canoe and Judy go 2.39 meters per second backwards, and Carmen dives off forward at 3.5 meters per second.